Hello, Algebra 2 students. I'll go through the answers to this practice quiz for you here. So in this first one, I'm going to pretend like my graphing calculator doesn't work, although you certainly can use that to check here. And I'm going to pick some easy x's, -2, -1, 0, 1, and 2. And then if I put a -2 in for x, I get 2 to the -2. That's the same as 1 over 2 to the +2, so that's 1/4 times 1/2 gives 1/8. Now if I put a -1 in here, 2 to the -1 is 1/2. 1/2 times 1/2 is 1/4. If I put a 0 up here, 2 to the 0 is 1. 1 times 1/2 is 1/2. Put a 1 here, 2 to the first is 2. Half of 2 is 1. And then put a 2 here. 2 squared is 4. Half of 4 is 2. It looks like maybe even 3 would be a good one to choose here, just so we can get that curve a little more accurate. So if I put a 3 in here, I get 2 to the third. That's 8. Half of 8 is 4. So those 4, or I shouldn't say 4, those 6 ordered pairs, that should get us a pretty good looking curve. So if I start with -2, it's just barely above the x-axis there at 1/8. At -1, it's a little bit more. At 0, it's half the way. At 1, it's 1. Now it starts to climb up. At 2, it's 2. At 3, it's 4. If we put a 4 in there, we could get that on this graph. It would give us an 8. So there's my curve. Exponential growth, as you can see, shoots up quickly when we get to that point. Whoops. And then is getting closer and closer, 1/16, 1/32, not quite getting to 0. It's almost to the x-axis, it never crosses it. That means our horizontal asymptote is the x-axis, which is y equals 0. Alright, these next two now. Get this out of the way. Doesn't require us to do any graphing. If we just look at our either growth or decay factors, that's where we can tell if the thing is growth or decay. So it's the base of this exponential part, the 1/4, that a value in our y equals ab to the x, that's irrelevant to whether it's growth or decay. It's all about what the base is. In this case, the base is bigger than 1. So part A is growth. And then for part B here, this 2/3, that's less than 1, bigger than 0, so that means it's decay. Problem number 3 here. We're going to use these ordered pairs to generate a couple of different equations with A and B so that we can figure them out. Right now we got 4 letters and just one equation, so that's not going to help us sort out what A and B actually are. So I'm going to take the 2 for the y and put it in here, copy the A and the B, and then it's also going to be power 2 because the x is also 2. So both x and y were 2. And then I'll solve this for A. So I'm going to divide away the b squared. So now A is 2 over b squared. Now I'm going to do this same process again for the second ordered pair. So now I can get 4, the y in the second ordered pair equals a b to the third. Now I've got 2 equations. I've got a equals this 2 over b squared, and 4 equals ab to the third. So now I can do substitution. I can take out the a and substitute in this 2 over b squared. That'll get me to just having one letter, and I can figure out the value for b here. So now 4 equals, instead of a, I'm going to substitute in 2 over b squared, and then that's times b to the third. I'm going to put that over 1 just to help you out here. So b squared underneath b to the third. You can use that division property of exponents, 3 minus 2, jump the line, change the sign. I get 4 equals 2b, which then gives 2 for my b value. Once I know the b value, I can quickly figure out the a value by substituting back in to this problem, or this equation that I have solved for a. So now a would equal 2 over 2 squared, which would be 1/2. So I've got my two values for a and b now, so I can write my equation. It's going to be y equals 1/2 2 to the x. That might look familiar. That's actually problem number 1 as well. Alright, this last one on this page deals with translations and these exponential functions. So the horizontal piece, that's the x piece. What zeroes it out? A -2 does, so that would be moving 2 to the left. So it is a translation of 2 to the left and 1 down. Let's take a look here. So if we would do this graph now, I would do the easier one, the y equals 2, 3 to the x. Get some values for that. This is the parent function. So that's the parent of this. So -2, -1, 0, 1, and 2. If I put a -2 up here, that gives 3 to the -2, which is 1 over 3 to the +2, which is 1/9. So I actually get 2/9 for that one. Put a -1 in here, I get 1/3 times 2 is 2/3. Put a 0 in here, that turns to 1. 1 times 2 is just 2. Put a 1 in here, I get 3 to the 1 is 3, times 2 is a 6. If I put a 2 in here, that's 9, times 2 is 18. Now, if we were to graph that one, you don't need to on this problem, but just so we can see that slide piece, -2 gives me 2/9. It's basically just above the x-axis there. -1, it's 2/3 of the way. 0 is up to 2. 1 is at 6. And 2 is off the grid up there. So generally speaking, my curve for this parent function, which you wouldn't need to graph this on here, I'm just doing it to show you guys here. There's the parent function. And now the slide, so this was, whoops, this is x and y here. So now the slide piece, we're going to subtract 2 from my x's, and we're going to subtract 1 from my y's. So if I subtract 2 from my x, I get a -4 there. If I subtract 1 from this 2/9, I get -7/9. If I subtract 2 from -1, that gives me a -3. And then subtracting 1 from 2/3, that gives me a -1/3. Subtract 2 from 0 is a -2. And then subtract 1 from 2 gives me a 1. Subtract 2 from 1 is a -1. And subtract 1 from 6 gives me a 5. And then this last one here, subtract 2 from that gives me a 0. And then I get a 17 for that one. Now if I graph those points, -4, -7/9, right there. -3, 1/3. Pretty much hard to tell the difference there. -2 shoots up to a 1. -1 goes up to 5. 0 goes up to 17, so it's kind of off the grid there. And so here's my new final answer 1. Notice the asymptote now is y equals -1. Wouldn't need that in there for this problem, but it's shifted down, and it's also shifted to 2 to the left, as you can see. So there you have it. Wouldn't need the parent function, so this is the only one you need, the red one. That's the parent, and then this one is. All right. Now to the back page. Whoops. That took longer than it should have. All right. So for graphing these log ones, it's really kind of 3 things you need to do. Do the parent exponential, flip that around, interchange the x and y's, and then do the slide on that. So my first table that I'm going to do is y equals 3 to the x. And I'll use my normal easy x's, -2, -1, 0, 1, and 2. And now when I put in a -2, I get 1/9. Put in a -1, I get 1/3. Put in a 0, I get 1. Put in a 1, I get 3. And put in a 2, I get 9. Now if I want to do y equals log base 3 of x, so I'm doing the inverse of this, I'm just going to switch around my x's and y's. So I'll do my y column first. That will just be my -2, -1, 0, 1, and 2. And then I'll put my 1/9, my 1/3, my 1, 3, and 9 for that. So now here's the parent function for this. And now I'm going to do the slide part. So that would be log, still base 3, x plus 2 plus 1. And so now for my x's and y's, I'm going to have to subtract 2 from my x, and I'm going to have to add 1 to my y to do the slide. So if I subtract 2 from 1/9, I get -1 and 8/9. Basically -2, really close. And then if I add 1 to that, I get a -1 for my y. Now if I subtract 2 from 1/3, I get -1 and 2/3. And I get a 0 for my y. Now if I subtract 2 from 1, I get -1 and 1 for my y. Subtract 2 from 3, I get 1. And add 1 to 1, I get 2. And the last one here, subtract 2 from 9, I get 7 and a 3. And I'm just going to graph this final result on this one, otherwise it gets a little busy. So if I graph these points now, -1 and -1 and 8/9 would be right about here. Whoops, I got that wrong. It's actually almost here, sorry. -1 and 2/3 would give me 0. About there. -1 and 1. 1 and 2. And 7 and 3. So we can see that asymptote for this one is actually x equals -2, and then it goes something like that. All This next equation is that PERT equation. A equals P times E to the RT. The rate has to go in as a percentage, the time is years, and this P for principal, that's this 5,200 in this problem. So for this one, we're going to put in 5,200 for that P. E is the base, and then we're going to have 0.074, so that 7.4% changes into a decimal, and then times the 13 up there in the exponent. After this, let's just type it into your calculator. If you do that correctly, you get the dollar amount to be $13,608.01. Money problems, just round to the nearest penny as usual. Almost there. Now can you change logarithms into exponentials? Can you evaluate logarithms? That's what these last two problems cover. So in this one now, I've got base 4, so that's saying 4 to the x equals this 1/16. I want to get the same bases, so I can see that I could say this is the same as 4 to the x equals 4 to the negative 2. So 1/16, jump the line, be 1 over 4 squared. So that gives me x equals negative 2. So x equals negative 2, or he's just putting negative 2 there, that's fine. All right, 3 to the x equals 81. 81 has got 4 3's in it, so 3 to the x equals 3 to the 4th, which then implies that the x equals 4 for this one. All right, last problem. Now, can you write an equation that's in exponential form? So we're going in the reverse. We had logarithm, we made it into an exponent. Now we're given a logarithm equation, make it into an exponent. So this would be 4 to the 3rd equals 64. So the base to this x number out here equals the y, the 64. So we get 4 to the 3rd equals 64. And then now this is a common log, so there is no number down here, but it's just hiding. It's a 10 there. So this would be 10 to the x equals 0.001. And I have let students use this since they got specific and figured out what the x was. 10 to the negative 3 equals 0.001. So either or. I would have accepted either for that one. The x is in the original, so I kind of prefer this top one. All right, hope that helped. Test is coming your way tomorrow. Have a good day.